When we did graphed circles, we came up with a standard form for a circle. There's a parallel standard form for a parabola. And I should show you that standard form because that's what the next group of problems are going to help focus on. So the standard equation for, I don't know what's going on with this paper, a parabola is f of x equals some number that we call a times x minus h squared plus k. Has a minus in the formula just like the circles did. And in this particular problem, the vertex for this formula is the point hk. If the a is positive, the parabola opens this way. If the a is negative, the parabola opens that way. And of course, if the a is bigger than 1, it gets narrow. If the a is less than 1, in between 0 and 1, it gets wide. Let me just show you really quickly on maybe my nice calculator. If I do this, f of x equals 3 times x minus 1 squared plus 4. My vertex of this parabola is going to be the point 1, 4. It's the number after the minus sign, and this the number after the plus sign, and it's going to open that way. And for what it's worth, it's going to be a little bit narrower because of the 3. It stretches it up. Let me show you this real quickly, that this isn't BS. So let me turn my y equals on, clear, and then 3 parentheses x minus 1 squared plus 4. 3 times x second insert minus 1 squared plus 4. Do zoom standard just in case I have a funky window. And let me show you that this is the point 1, 4 very lazily. I'm going to go second, hit the calc trace key, hit enter, tell my calculator to plug 1 in, and it shows you that the vertex there is the point 1, 4. So the vertex is 1, 4. This is a narrowish parabola because of that 3, and it's a regular size up parabola. Let me do another one. How about this? F of x equals to 1/2 times x plus 5 squared minus 6. It's not quite standard form because it doesn't have the plus. Just like when we had parabolas, we could make a plus into a double negative. So I could write this x minus negative 5 squared minus 6. I'm usually a little lazy with parabolas. I usually don't put it into the pure standard form. I can pull the vertex off of this equation as well as this equation. But for this guy, since I've made it directly into perfect standard form, it has a minus in the parentheses with a square outside of it. The number after the minus sign is the x coordinate of the vertex, and the number after the square with its sign is the y coordinate of the vertex. So this is going to have a vertex of -3, -6. For the heck of it, let me make this negative just so I can flip it over. Make this -1/2 out front, -1/2 out front. The negative, since I decided to do that, is going to make it go upside down. The 1/2 is going to make it wider, and so this is going to be upside down and a bit wider because of the compression. But let me just show you this real quickly on this calculator. So y equals clear. I'll do the fraction properly. So I'm going to hit my math button, go over to fraction and hit enter and do negative 1/2. Can't do that on my old calculator. Times x plus 5 squared minus 6. Graph it. It's upside down. It's wider than the last one. I claim that's the point -5, -6. I'll show you it real quickly. I'm going to go second calc, value, type in x equal -5, and my cursor shows you that's -5, -6. So this is standard form with the minus signs in the parentheses. I can, with a parabola, pretty comfortably tell you what the vertex of each one of these is. If there's a minus, basically the x coordinate of the vertex, I change the sign of the number in the parentheses. The y coordinate of the vertex, I keep the sign. So here it was 1, 4. Here it was -5, -6. I usually get a little more lax with parabolas because it's less going on. There's only one vertex as opposed to the 2 parentheses what we had in circles. So the problems that we need to work with now are written, so I couldn't tell you what the vertex is. I don't know what the vertex of number 14 is. So what I need to do for problem 14a is rewrite it so I can tell you that the vertex, because I just graphed this here, this is the vertex is -5, -36. There's not a number in front of the x squared. I think the equation of this parabola is f of x equals to either x plus 5 squared minus 36 or x minus -5 squared minus 36, I think. You're not supposed to know anything yet. So how do I get this into something that I can tell the vertex is -5, -36? I do that by completing the square. Very specifically, I'm going to take the problem that's presented and I'm going to add a c to do completing the square. What I'm going to do is I'm going to group the x's and put them in a parentheses, and I'm going to put the constant outside the parentheses. So my problem had an x squared plus 10x, I call that the x's, shove them inside a parentheses. The constant minus 11 I put outside a parentheses. Inside the parentheses I'm going to add c, outside the parentheses I'm going to subtract c. That keeps the problem balanced. If I drop the parentheses and combine like terms, the c's would cancel and I would have the original problem. So first I add and subtract c. Eventually this is going to get a little more complicated, but for now we'll just live with this. The adding c is not going to change. The subtracting might change in a little bit here. Now I'm going to find c. And we hopefully remember how to do that. I'll say c is b over 2 squared, where b is the coefficient of the first power term. So in problem 10, c is going to be 10 over 2 squared, which is going to be 5 squared, which is the number I'm going to use for my factoring, because I'm going to factor lazy like we did with circles back in chapter 2. C is 25. So I grouped my x's, put them in a parentheses, made my constant go after a parentheses. I'm going to compute c, and I'm going to change the c to my number. So I'm going to get g of x equals to x squared plus 10x plus 25 minus 11 minus 25. And then I'm going to lazy factor the x's, and I'm going to combine the constants. Those are the numbers outside the parentheses. So first I grouped the x's and the, so I should say grouping first. Group the x's. Group the x's, add and subtracted c's, figuring out what c's is just like in chapter 2. Add and subtracted c's, and now I'm going to factor. If I could go from here to there, that's what I should do. If I didn't remember I could factor speed fastly, this would factor like this. The x squareds would split as a couple of x's, because x times x is x squared. After the x's, the numbers have to multiply to 25 and add to 10. And 5 times 5 is 25, 5 plus 5 is 10. So the numbers that would go in the parentheses are always this number. You always get two identical parentheses. The constants are both negative, so I'll add them and keep them negative. And now I'll rewrite the problem so it only has one parenthesis with an exponent of 2. This is considered using completing square to write the problem in standard form. So for an answer to part A, if I don't mind the plus sign in the parentheses, then I can live with that. If I don't like the plus sign, I could change it to that. But then that's going to mess up this part. Describe the transformation. This is a little bit backwards because I didn't tell you the function. This function really is f of x plus 5 minus 36 if the seed function is x squared. If I asked if the seed function was f of x equal to x squared and I asked you to find this, you would get that function. The plus in the parentheses is going to move the graph left 5. The minus is going to move it down 36. And then sketching a graph, I'm going to make the worst table in the world, but it'll be good enough. I'm going to take the sign of the plus 5, change it, put it in the middle of my x column, and go up and down. This time just 1. I don't need 5 points. 3 is the minimum point number of points to graph a parabola if the middle one is the vertex and you get a point on either side. So now I enter my function. I could either enter x squared plus 10x minus 11, which is the original problem, or I can write some version of my answer, x plus 5 squared minus 36. They both will have the same y's. In fact, if I enter the original function in y1 and the second function in y2, and I go to look at my table, my answer is only right if the y's match. If the y's don't match, then the equations aren't equal to each other, and you made a math error. So the points that I should plot are negative 6, negative 35, negative 5, negative 36, negative 4, negative 35. And you can plot more points. I plotted more points, but it's okay if you don't plot so many points. That's everything. Let me show 13 on the screen. And I'm going to jump and do 16. Same style of problem. I'm going to get this written in standard form. So to get this part A of number 16, first I'm going to group the x's and place them in a parentheses. So I'm going to rewrite the problem to help myself out. I'm going to say the function m of x equals to x squared minus 2x plus 6. So I've grouped my x's. Now I'm going to add slash subtract c. I'm going to get m of x equals x squared minus 2x plus c plus 6 minus c. Next, I need to change the c to a number. I need to compute c. Compute slash substitute c. C is always based on the number in front of the x to the first power term. So c is going to be negative 2 over 2. You divide that number by 2 and then you square it. Negative 2 over positive 2 is negative 1. That number is going to come up in my factoring, but I don't need it on this step. And negative 1 squared is positive 1. So now I'm going to get m of x equals to x squared minus 2x plus 1 plus 6 minus 1. Now I'm going to factor in a lazy fashion and combine. What am I going to factor? I'm going to factor this. And when I'm using completing the square, the factoring always comes out to a parentheses with an exponent of 2. The parentheses always leads with an x. It always ends with the number in my computation right before I squared. And then the 6 minus 5 is positive 1. Oh, 6 minus 1. I don't know why I did the math in my head. This is 6 minus 1 here. I'm supposed to add and subtract 1. I did 6 minus 1 in my head and got the 5. So this should be my equation. That's my answer to part A. So for part A, the equation is m of x equals x minus 1 squared plus 5. And if I was shifting from x squared, this guy right here, the minus in the parentheses, would move it right 1. I should probably have an m written there. I should have different function names, but it is what it is. It doesn't matter. A minus inside a parentheses will move the graph right. A plus afterwards will move the graph up. This comes up a ton in our class. And to graph this, I would change the sign of the negative 1, put a positive 1 in the middle of my x column, grow bigger and smaller. Use my calculator. This is going to be my vertex. I know it's going to have a y of 5, but I don't need to know that. And to make sure my answer is right, put the original function, x squared minus 2x plus 6 in my y1. My rewrite of the original that should equal the original, x minus 1 squared plus 5 in y2. Look at my tables. If my y's are the same, my answer is good. If my y's are different, my answers are bad. Next to 0, I get 6. Next to 1, I get 5. That's my vertex. I actually should know that ahead of time. And next to 2, I get 6. Plot those 3 points, connect them, and get your parabola. There's one evil trick that's coming up. So this is your problem 15. You should give it a go. And the evil trick comes on 17. Let's do 17 together, because there's a common factor with the x's. So let me start here doing my part A. I'm going to group the x's. The big star here. If there is a number in front of the x squared, it just gets bad. If there's a number in front of the x squared, add the step. Factor out the GCF. Before worrying about the C's. So there's going to be an extra step here because of the 2 in front of the x squared, and it's the horrible step. So for 17a, I'm going to start off and rewrite this. I'm going to say f of x equals to 2x squared plus 8x minus 3. In the first 2 problems that I did, there wasn't a number in front of the x squared. That's the best thing that could happen. If there's a number in front of the x squared like there is here, I need to factor out that as a common factor. The x squared in the parentheses can't have a number in front of it, or this strategy doesn't work properly. So I'm going to pull out that common factor, and that also weighs on the c when we get there. So that's my extended first step, and it's going to horribly mess up the c's. So I grouped my x's. Because there was a common factor, I pulled out because there was a number in front of the x squared, I needed to pull that out as a common factor. I didn't even do it right. I don't know how many mistakes are in this video. I've been working for a long time today. Just doesn't feel like I'm ever going to get done with this rewrite of this class. So that's better than leaving the 8 there. Now the c. I'm going to add c, but I can't just subtract c. If I cleared the parentheses right here, if I cleared the parentheses, I'd get 2 times x squared to clear the parentheses, 2 times 4x to clear my parentheses, and 2 times c. If I cleared the parentheses, I'd get 2x squared plus 8x plus 2c. If there's a number in front of the c, you need to put that number in front of the c when you subtract. Because here, even though it looks like I just added c, I've really in hiding added 2c, so I need to subtract 2c. So I need to multiply to figure out the c. Now I'm good. Now the rest is the same. So double trick. If there's a number in front of the square term, we need to factor it out. And that number needs to be multiplied by the c. So let's get into this now. Let's figure out if we can get this nailed now. Let's figure out what c is. C is going to be this 4 over 2 quantity squared, which is going to be 2 squared, which is going to be 4. So I can rewrite this as f of x equals to 2 times x squared plus 4x plus 4 minus 3 minus 2 times 4. This I can factor lazily. It always factors into one parenthesis with an exponent of 2. And inside that parenthesis, other than the x, I'm going to get this plus 2. So this is going to give me f of x equals 2 times x plus 2 squared. And this is minus 3 minus 3 minus 2 times 4. I get minus 11. So my answer to part A, the rewrite of this is going to be f of x equals to 2 times x plus 2 squared minus 11. And now I should be able to see the shifting even though I don't have the seed function. A number in front of the parentheses, if it's bigger than 1, compresses. If it's in between 0, if it's bigger than 1, it stretches. If it's in between 0 and 1, it compresses. So here, for my description, that 2 is going to stretch the function as opposed to compress it. A plus inside the parentheses is going to move the graph left, and in this case 2. And that minus after the parentheses will move the graph down, which is going to be 11 down. When I go to make my table calculator only, I'm going to take that 2, change its sign, put it in the middle of my x column. That's going to be the x coordinate of my vertex. Go bigger and smaller by 1, so -3, -2, -1. Enter both functions on my calculator. So on my y equals, do 2x squared plus 8x minus 3 and 2 times x plus 1 squared minus 11. Check my tables. If the y's don't match, I have a mistake. I have a mistake. My y's aren't matching. That makes complete sense because I am fatigued. So first function, looks like I wrote it right. Second function, looks like I wrote it right. What did I do wrong? -3 minus, I don't even know what I did wrong. 2 times x plus 2 squared looks right. I don't even know what I did wrong. minus 3 minus 8. I don't know what I did wrong. This is not good. I don't feel like doing this video again. Clear, clear. 2x squared plus x minus 3, enter 2 times x plus 2 squared minus 11, second table. Oh, now they match. I just entered something wrong on my calculator. Lord knows what it was, but doesn't matter. So next to negative 3, I get negative 9. Next to negative 2, I get negative 11. Next to negative 1, I get negative 9. I plot those points. The negative 2, negative 11 is going to be the vertex. Kind of just have time for one more. So I think rather than making us do the ones that have the negatives, which this is just not the most important skill in the world, I'm going to do problem 8. In fact, let me just make up a problem to parallel number 17. Oh heck, I'll just do 18. We'll just say for this group of problems, we're going to stop at 18. So for these problems that started at number, in this grouping of problems, we just want to do 13, 15, and 17. And we won't worry about the problems between 18 and like 20 something. We'll go to the next part of the video in a second. The next group of problems have negatives in front of the squares, and that just adds another layer of mixed up for the C's. So in this group of problems, and that's the group of problems between 13 and 24. So in the problems between 13 and 24, just do 13, 15, and 17. Let's do this one together because I already stole your 17. So to start this problem, I'm going to group the x's. 4x squared plus 24x plus 30. I would go straight into adding and subtracting c, but that 4 in front of the x squared makes it so it would mess up if I do that. So I'm going to pull out my common factor of 4. And now I'm going to add and subtract c. But when there's a number in front of the parentheses, you can't just subtract c. You have to multiply the number in front of the parentheses by the c and subtract that. So I'm going to subtract 4c as opposed to just c. If there's no common factor, you just subtract c. If there is a common factor, you multiply that common factor by the c. Now I'm going to figure out what c is. C is always half of the number in front of the x to the first power term divided by, it's the number in front of the first power term divided by 2 and then squared. 6 divided by 2 is 3, and 3 squared is 9. So what I'm going to do is inside the parentheses, I'm going to add 9. Outside the parentheses, I'm going to subtract actually 4 times 9 when I change the c to 9. Super easy to factor. I'm going to leave the 4 in front of a parenthesis that has an exponent of 2, and the number part in that parenthesis is going to be this positive 3. That's going to go after the x. And then the constant part of this, 30 minus 4 times 9 is minus 6. So I think my answer to part A is h of x equals 4 times x plus 3 squared minus 6. To describe a number in front of a parenthesis, if it's between 0 and 1, it compresses. If it's bigger than 1, it stretches. So I'm going to say this graph is stretched. A minus inside a parenthesis is right, a plus inside a parenthesis is left, and a minus afterwards is down, a plus afterwards is up. I could put this in standard form and tell you that the vertex is -3, -6. I can inspect and get the vertex. Change the sign if there's a plus or make it into a double negative. The x-coordinate of the vertex is -3. The y-coordinate of the vertex is -6. For my table, change the sign of the +3 to -3. Fill up my x column with numbers bigger than smaller. And then in my y equals, put 4x squared plus 24x plus 30 in y1. My answer, 4 times x plus 3 squared minus 6 in y2. Pull off my tables. The y's have to be the same. If they're not the same, then I have a mistake, either in entering it on my calculator like I did on the last problem, or in my algebra. And then get those 3 points, plot them, and then we'll call this part of the video done. Even though I didn't get to everything I wanted to, it's enough. It's way more than enough than you'll need for the test. On the test, I believe we have a problem like this.